is 0.5 kilogram ball strikes the rough ground surface and rebounds with the velocities shown. Neglect the ball's weight during the time of impact on the ground. So we have to neglect the weight of the ball, and you have to just draw a vector of like a rebounding force. So it will have this impulse, since force is, in this case this is a constant value, so I can find out I, which is this is impulse. So let's find out. So from the linear impulse and momentum equation which we just studied, let me grab this equation here. So this one, I want to grab this equation to solve for this problem. So this is my equation of linear impulse and momentum, and we want to find, let's assume this is my impulse. This is correct. I stands for impulse as mentioned here. So you just have to find I equals to mass v2 minus v1. And if you take a look, this is my v1 vector. Okay, this is my v1 in terms of two components. So I'm going to draw the reference axis. I-axis positive to the right, upward j-axis, y-axis, unit vector upward is positive. So I'm going to resolve this into two components. This force velocity vector, resolve this into two components, and you will see this velocity vector, it's a vector in terms of j and or I and j. So let's see, let's resolve this. So v1 vector, this component, let me bring this down here, and plus this component. So if you take a closer look, this is 25 hypotenuse, this is like hypotenuse times cosine 45. So kind of write down 25 cosine 45, positive direction, this is to the right, so it's positive. The other one, this one is 25 sine 45, but the negative direction, so I can write down 25 sine 45. So this is the resolution of vector in terms of I and j components. Let's resolve the other vector, velocity vector, in terms of I and j components. So this is like 10 cosine 30 I unit vector, plus the other vector, this is also positive direction, so it is 10 sine 30 j unit vector. Now we have resolved it. Let's plug it in this equation over here, equation 1. So I equals to mass of this ball is 0.5 kilogram. So I'm going to write down 0.5. I will write down individual components. So v2 minus v1. So I'm going to write down 10 cosine 30 minus 25 cosine 45. This is the ith unit vector. You have to subtract corresponding unit vectors. You cannot subtract I from j. You have to subtract j from j. So v2, this is the v2. So I'm going to write down this component first. Minus this minus and this minus becomes plus. So I'm going to write down plus 25 sine 45. And you can help me with the resolution. So you should get minus 4.51 I unit vector and plus 11.34 j unit vector. So this is the impulse, which is a vector quantity. So if you want to find out the magnitude of the impulse, you have to do the Pythagoras theorem for rectangular coordinates. And if you solve for this, you get 12.2 Newton second. This is the magnitude. This is your answer.